Currently, fossil fuels provide 84% of the world's primary energy, with 33% coming from oil, 27% from coal, and 24% from gas. And only around 16% of worldwide energy comes from low-emission sources, including just 4% from nuclear energy. From the past 20 years, energy production from fossil fuels continues to rise, as nuclear energy is gaining popularity as the world gets less comfortable to live in as a result of climate change. But it has remained constant for the last 20 years in terms of energy production. As a result of increasing greenhouse emissions, we surely have to move away from fossil fuels and should consider nuclear energy as a replacement. It is another alternative to fossil fuels, and although it's not renewable, it's greenhouse gas emissions that are negligible in comparison to fossil fuels. Before we go any further, we should first understand how nuclear reactors work and its consequences. All nuclear plants produce energy by nuclear fission reaction. Nuclear fission generates millions of times the energy of any chemical reaction. Neutrons strike extremely heavy elements on the verge of stability, such as uranium-235. Although the neutron is absorbed, the outcome is still unstable, which usually divides into fast-moving lighter elements, a few extra free neutrons, and energy in the form of radiation. It's a tightly controlled chain reaction. The radiation heats the surrounding water, while the neutrons repeat the process with additional atoms producing more neutrons and radiation. As in uranium breeding cycle, when neutrons strike on the uranium-238, it converts into plutonium-239, and further neutrons bombardment results into nuclear fission reaction and release energy. But nuclear power does come with certain concerns like disposing of radioactive waste from nuclear power plants. It's a challenge. And what do you do with such dangerous byproducts like plutonium? It's highly dangerous, and it's the most commonly used material for nuclear bombs, which is one of the reasons scientists have continued to look for alternatives. Thus, thorium. It's important to remember though that thorium is not a fuel like uranium. The distinction is that uranium is fissile, meaning it can cause a long-lasting chain reaction if enough uranium is gathered in one place at a time. Thorium, on the other hand, is fertile, meaning it can transform into the fissile uranium isotope, uranium-233, if bombarded with neutrons. There are various ways that thorium could be used to generate electricity. The use of solid thorium and uranium-232 fuel in a typical water-cooled reactor comparable to modern uranium-based power plants is currently being investigated. In reality, thorium and uranium-233 fuel have been used in more than 20 reactors throughout the world. The molten star reactor is another concept that has driven the interest of scientists and fans of nuclear power. Fuel is dissolved in liquid salt in these plants, which also serves as a reactor coolant. Because the salt has a high boiling point, it can be used to generate energy more efficiently. And even big temperatures spike, which will not result in massive reactor tragedies like the Fukushima one in 2011 and Chernobyl in 1986. This type of reactor may sound like something out of science fiction, yet many reactors like these were under operation in the US and Germany from 1960 to 1990. But why we consider thorium as an ultimate solution? Because it offers some significant advantages in terms of power generation. Uranium-233, which is created from thorium, is a more efficient fuel than uranium-235 or plutonium, and its reactors are less likely to melt down since they can operate at greater temperatures. According to some sources, our current thorium reserves can power whole of China to its all-energy requirement for the next 20,000 years, which means we have plentiful thorium to go with. Also, during reactor operation, less plutonium is produced, and some experts believe that thorium reactors could remove the tons of deadly plutonium stockpiles that have been created and stored since the 1950s. The waste residues from thorium fuel cycle are far less than uranium or plutonium fuel cycles. This is a crucial argument for the protection of our planet because it has an environmental benefit. We all know that the world's uranium reserves are limited. Natural uranium demand will be decreased by around 20% if thorium-based nuclear fuels are used. Because of the decreased plutonium-239 generation, thorium-based nuclear reactors have been declared absolutely non-proliferative for all practical purposes. This is a unique advantage of this type of nuclear reactor in terms of ensuring nuclear non-proliferation while also eliminating the risk of nuclear weapons. Despite these advantages, it comes down to certain problems like during the neutron bombardment, thorium-232 can also be transformed to uranium-232 instead of uranium-233, which decay to produce gamma radioactive products. This would get complicating fuel recycling and reprocessing, and it requires handling techniques and precautions like plutonium-239. The majority of thorium ores are low grade. As a result, extracting thorium from these types of ores is a challenging operation, and truly cost-effective thorium extraction technologies have yet to be developed. Also, the majority of significant thorium ores are located in developing nations such as Brazil, Turkey, Egypt, and India, which rely heavily on the technical and economic assistance of developing countries. Thorium-based nuclear fuel cycles have been available for nearly 50 years now, and while they have caught the curiosity of the nuclear community at various times, technological advancements have not been sufficient for their practical use in today's energy production systems. The geographical dispersion of thorium and uranium deposits was the primary cause of this delayed technological advancement. This indicates that if the world's technological leaders, such as the US, Canada, and France, had more thorium deposits than uranium, technological development would almost surely favor thorium over uranium. This indicates that thorium will most likely be a far more valuable nuclear element than uranium in the future. As a result, all emerging nations with thorium reserves, such as India, should focus their technological efforts on evaluating their national thorium deposits and cooperating with one another. This may be accomplished with the help of technological leading countries like Japan, who has the potential to play a key role in achieving this coordination, and to become a leader in the required technological development programs for the use of thorium in future energy systems. Nuclear energy cannot be abandoned due to rising global energy demand year after year. Hence, long-term nuclear energy production systems should be built. Thorium is seen as a brightened star of the new nuclear technology period on the horizon of the 21st century. What do you think about thorium-based nuclear power systems? Let us know in the comments, and if you want to see more stuff like these, consider subscribing to us. So stay tuned, give us a like, and make sure you hit that bell icon so you never miss out on any amazing videos that we post. Thank you so much for watching.